Have you ever imagined that, right beneath your feet, there are structures so gigantic and ancient that they could change everything we thought we knew about the interior of the Earth? Well, these underground islands, located near the planet's core, have intrigued scientists for decades. And the most surprising thing is that new research shows that they may have an origin as mysterious as it is revolutionary, capable of shaking up our understanding of the Earth's mantle once and for all. But before revealing the most surprising details, which include the possibility that they are the remnants of a lost planet or the result of billions of years of tectonic plate subduction, let's start by understanding where these colossal formations fit into the geological history of the Earth and how they can influence volcanoes, mountains, and even the way we see the composition of the planet. Get ready for a scientific journey full of speculation that promises to challenge the way you imagine the world beneath your feet. These structures, known as low shear velocity provinces, or LLSVPs, are so extensive that they occupy between 3% and 9% of the planet's total volume. It's as if there were continents hidden deep beneath Africa and the Pacific Ocean. Discovered in the 1970s, they were nicknamed blobs due to their massive appearance, which is different from the normal mantle. There, seismic waves move more slowly, which indicates higher temperatures or peculiar compositions. Just imagine a giant cake inside the Earth, with ingredients so different that they interfere with the speed at which earthquake vibrations pass through it. It is precisely by analyzing these seismic echoes that scientists can map the depths, a kind of tomography of the planet, bringing to light information without anyone having to dig through 3,000 kilometers of rock. To understand why these LLSVPs are so mysterious, just remember that the interior of the Earth is inaccessible. Drillings only reach a few kilometers below the surface, while these formations are thousands of kilometers deep, close to the core. So, each earthquake, each seismic tremor captured by seismographs spread around the world, provides valuable clues. It works like this. Depending on the density and composition of the material that the seismic wave passes through, the speed of the wave can change. By comparing this data, scientists create 3D maps of the interior. In this process, these two giant islands became evident, each with an immense volume, such as Tuzo under Africa, which is estimated to be 800 kilometers high, about 90 times higher than Mount Everest. In other words, we are talking about something truly colossal, which could, for example, play a fundamental role in the formation of hotspot volcanoes, such as those that gave rise to the Hawaiian archipelago. What makes everyone even more curious is the origin of these formations. There are basically two major theories. The first suggests that these LLSVPs are accumulations of oceanic crust subducted over billions of years. Think about how many tectonic plates have sunk since the planet cooled enough to have a solid surface. And as these plates descended, pieces accumulated there, so that, after so much time, they ended up forming these megamasses with a different composition and greater density than the surrounding mantle. The second theory is even more intriguing. Some research points to the remains of Theia, a hypothetical planet the size of Mars that would have collided with Earth about 4.5 billion years ago, generating the Moon as a byproduct of this cosmic shock. If part of Theia's mantle remained inside the Earth, denser and more resistant, this would explain why these LLSVPs can survive the agitation of the mantle for so long. A recent study has brought to light information that is even more intriguing. These formations appear to have huge grains and lose very little seismic energy, which indicates that they are relatively rigid and old. Normally, in regions where plates are subducted, the smaller grains cause seismic waves to lose more energy, as if they were passing through terrain full of small stones, capable of muffling the sound. But in LLSVPs, the waves are more audible and practically do not dissipate. This points to a material that is very different from the rest of the mantle, and also to the possibility that these structures do not actively participate in mantle convection, that constant movement of material rising and falling that drives the formation of volcanoes, mountains, and even continental drift. In other words, they would be a kind of fixed blocks since time immemorial, surviving geological transformations for billions of years. If this hypothesis is confirmed, it could challenge the traditional notion that the mantle is completely mixed and homogeneous on a large scale. We already know that there are local differences. After all, it is this difference in temperature and density that makes convection happen, but these mega-islands could be proof that there are real fossils from the early Earth hidden down there. This would have enormous implications for understanding surface geological phenomena. If mantle plumes, masses of hot rock that rise from the mantle, really originate at the edge of these LLSVPs, then volcanoes like those in the Canary Islands, Hawaii, or Iceland could, in theory, have much older connections to the formation of the planet than we imagine. It is as if, every time a volcano erupts, it is bringing a little piece of a deep past, perhaps even before the formation of the Moon, directly to the surface. And the research didn't stop there. Using seismographic data collected since the 1970s, literally half a century of earthquake records from around the world, scientists can study these structures in depth without having to wait for new seismic events. It's the equivalent of having a vast library of underground sounds, ready to be analyzed with increasingly advanced data processing techniques. This means that with each new algorithm, with each new way of interpreting the signals, an insight may emerge that unravels the mystery of the exact composition of these secret, ancient islands. Perhaps they are pieces of oceanic crust, perhaps relics of Theia, or even some other explanation that no one has yet imagined. Whatever the case, these giants hidden in the heart of the planet seem ready to tell us entire chapters about Earth's history that have never been revealed before. When we think about such ancient structures, it is inevitable to remember how all of this is connected to the great events of the geological past: continental drift, the formation of supercontinents such as Pangaea, and even the great mass extinctions, which may be linked to supervolcanoes originating in mantle plumes. In fact, the history of the planet goes far beyond what we see on the surface. In each of these episodes, the mantle and the core may have played a crucial role, controlling the dynamics of heat and the movement of tectonic plates. Now, with these LLSVPs entering the scene, we are invited to rethink several theories. After all, they behave like large islands, resistant to convection, holding secrets as old as the solar system itself. With each discovery like this, it becomes clearer that knowing the interior of the Earth is not just an academic luxury, but something that directly influences our life on the surface. The distribution of earthquakes, the location of precious minerals, the formation of mountain ranges, and the existence of active volcanoes can all be directly linked to the nature of these deep masses. Knowing the Earth in depth, literally, is also a way of predicting risks and understanding how the crust, mantle, and core interact to shape the planet we call home. And who knows, in the future we might even be able to create technologies that monitor these mysterious regions in real time, helping us anticipate natural disasters or find resources more efficiently. The fact is that each step we take in understanding these colossal structures brings us a little closer to understanding the Earth as a living, dynamic system. And now I want to know from you, what do you think of these mysterious mega-islands hidden deep inside the planet? Do you believe more in the theory that they are the remains of tectonic plates or pieces of an ancient world called Theia? Leave your opinion in the comments. Share your questions and let's continue this fascinating discussion. And, of course, if you like this video and want to follow more curious discoveries about our planet and beyond, don't forget to like and subscribe to the channel. This helps to strengthen our community and ensures that we continue exploring the enigmas of the universe together. Until next time.